All right. Well, welcome everybody. I'm going to get us started right on time here because we have a jam-packed agenda with lots of great presentations. I want to save some time for questions as well. Thank you again for joining us today. My name is Kyle Shelton. I'm the director of the Center for Transportation Studies at the University of Minnesota, and we are the organizing logistical partner for Towards Zero Death, Minnesota Towards Zero Death, and want to welcome you to this Hotdish Research in Action, Perspectives from Minnesota Traffic Safety Research Ecosystem. We have some great presentations from both colleagues here at the university and then several from our partners here at MnDOT, and really delighted to dig into these. I think it's going to be a really interesting set of conversations and presentations about what folks are working on, and looking forward to hearing your questions as well. Before we jump into some logistics, I want to make sure to thank all the partners in the Minnesota Towards Zero Death program. That includes NHTSA, the Departments of Health, Public Safety, and Transportation, and all of you for working on what you do to keep people safe on our roadways and no matter how they're moving. So thank you for all the work, and thank you particularly to those sponsors. Just a couple pieces of information here. This is being recorded and will be posted to the Minnesota TZD site. This is a webinar format. If you haven't been in one in Zoom before, all of you all as attendees are muted. You can't interact directly with myself or other panelists, but you can, I'll show you in just a second, comment on in a couple different ways. Professional development hours are available for this and can be found on the TZD program webpage, and there's a link for that there if you need that. If you do want to leave questions, please use the Q&A for questions at the end. We're going to allow the presentations to all carry out, and then we'll do questions at the end with the last 10 or 15 minutes or so. If you need technical assistance, however, or have a comment or an idea you'd like to share with everybody on the webinar, you're welcome to put those in chat, and we'll be monitoring that throughout. But if you do have a question, I'll be looking at the Q&A function at the bottom of your screen, and would appreciate you putting them in there so I can walk through those at the end. With that, I think we're on to the introductions of our speakers. I'm going to go through all four briefly and then hand over to Jackie to start us off. So Jackie Duran is a program manager and research engineer with MnDOT's Office of Research and Innovation, and works closely with the local road research program, which is a great effort here in Minnesota to connect local needs, city and county, with research from partners across the country and in Minnesota. And then we have Max Moreland, who is a traffic safety crash data engineer within the MnDOT Office of Traffic Engineering. And Dr. Nicole Morris is the director of the Human Factor Safety Lab and a research associate professor in the Department of Mechanical Engineering, and has done a range of great projects, and I'm excited to hear about what she's working on. And then last but not least, we have Mark Wagner, who is the Assistant State Traffic Safety Engineer, also in MnDOT's Office of Traffic Engineering. So thank you all for joining, and you'll hear from each of them in turn here, starting with Jackie, and you all feel free to add more context to your bios if needed, but appreciate you being here and looking forward to hearing you. And I'll jump on at the very end and maybe ask a question or two, but then we'll look to the audience as well to have questions after all four presentations. Thanks, everybody. Take it away, Jackie.
Great. Thanks so much, Kyle, for that introduction. I have been attending the City Engineer Traffic Safety Committee meetings for a couple of years now, and I'm always so impressed that in that meeting, this group can bring in speakers and contributors from Office of State Aid, from Traffic Engineering, city engineers, CAVX office. And so this group is also already partners really well. And I think partnership is at the core of what we do in our office as well. You're one of our most connected and successful groups in terms of research. So I'm going to share some of our partnerships, programs, pathways, and also leave you with some tips and ways of leveraging the services that we offer and through our programs, so that you can leverage those resources. So safety and people and partnerships are all part of our strategic plan. Our office of about 24 people includes research management, marketing communications, library services. We have contracts and finance, and our work is centered around these goals and strategies. Here's a snapshot of our fiscal 2024 research funds by source, and you can see that these local, state, and federal funds are all really important to our programs and really help define our partnerships as well. Traffic safety topic is research funding is trending upward. Here's a trend from the last 5 years. And you're our second highest funded research topic behind materials and construction. So again, our partnerships are strong. MnDOT both has programming and funding for research. The Local Road Research Board, this is our new logo, by the way. The same, different groups, but they also they fund and we manage research. And a lot of times we work together jointly, making sure that we're not duplicating efforts, and we sometimes jointly fund. MnRoad is just one of our MnDOT offices that actually funds and conducts their own research. I show them here. The Office of Traffic Engineering also, and some other CAVX office does their own research. MnRoad is just a great partner with their test tracks, their low volume road to pilot some of these things that we're doing and we're learning from research. The University of Minnesota, specifically Center for Transportation Studies, is an important partner, especially with training and tech transfer. They provide many academic researchers, and we also have about 15 other universities that do research from the programs we manage. I'm showing a partial list here of our pooled funds. These pooled funds are multi-state research projects. Here's just a few of them you might be familiar with. Minnesota leads 8, and we participate in more. And for every dollar that we spend in a pooled fund, we leverage $10 worth of research. So we love those. So our office helps you determine the best pathway for your idea. Ideas start from different levels of maturity. Sometimes it's a new emerging topic. Sometimes it's building off of phased research. And so one of the things we do is we often start with literature search from our MnDOT library. And that could be something that, you want to know what other states or other agencies are doing. What is, what are some of the best information out there, and our library services can help with that. Next, we have the research synthesis, and this is something that is meant to be quicker turnaround than our research projects, which last 18 to 24 months. These research synthesis, they often precede a research project and help us focus on, what is it that we want to get to with the research project. Help us with our direction for that. And research projects are academic research, and there's pathways within this pathway in terms of need statements that are written and come directly from our programs. We also have a direct pathway for the University of Minnesota for knowledge building. And then we have a flexible pathway as well, each cycle for emerging topics, things that come up and things maybe we didn't know. Research implementation, excuse me, is just that. All of our programs do implementation. I would say the Local Road Research Board has a very robust program with every 5 academic projects they do about 20 implementation projects that produce those guides and tools, and they're at the end, those next steps after research. And then innovation is something we foster in our office. Innovation isn't new to anybody, but what we are doing currently is standing up a dashboard to highlight some of those innovations that all of the offices within MnDOT are doing. And we're also planning a fall recognition event, and hopefully we can expand this to external partners as well. So you might want to know, where do research ideas come from? How do they get, where do they come from before they get funded? And my answer is that they're very much subject matter expert and practitioner driven. We have these relationships and these processes in place to gather those ideas. Um, and even the ideas that are coming directly from our academic researchers are paired with champions, subject matter experts who help guide that research and have an eye to, what is going to be useful to practitioners. So here's our academic research cycle. And with sustained funding, we repeat this each year. And you can see why we have over 100 projects that we're managing at one time. These just cycle through. And we have touch points with our with partners throughout this whole process, through each stage. And so in any one year, we have consultants, we have a lot of different people that partner. And in any one year, for example, our partners in traffic engineering, say Mark Wagner, he might have an idea that he submits to our idea scale website. He might review others' ideas. He might help with proposal development or reviewing proposals. He might be a champion and present these proposals to the boards for funding. And then at the end, if a project's funded, he may continue on a technical advisory panel or a technical liaison and lead that. So we really have a lot of touch points with this process. Our technical advisory panels, we have over 850 unique TAP members statewide that contribute to our projects. And they are offering guidance on our research. They are oftentimes they're providing data and coordination on the different tasks with the project. And they're very important to disseminating the knowledge that we gain from our research and implementing. So I'm going to share just a few of our specific traffic safety related activities, and I'm going to provide a QR code with all of these linked at the end. I just wanted to show you what we're working on with the syntheses listed first and some implementation that is being done both through the MnDOT program and local road research board. And you can see with those active research synthesis, some of these emerging ideas, you can see what the authors are trying to get at. Okay, we have this new idea, and we want to try to focus on what should our research be and what should we do next. And these are our most recent academic research projects that are kicking off this summer. And thanks to anybody who might be in this webinar who are on the TAPs for these. We're excited to kick these off. Some of the deliverables you might be familiar with, but you can expect from our research include research summaries. These are 2-page summaries that answer, that tell what we did, why we did it, what we learned, and what is next for that topic. We and our consultants produce videos. These are popular with the local road research board, and we try to go back occasionally and update these as well. These are great tools for city county engineers in particular. Here's an example of a synthesis flyer that is trying to share an app with people. And here is an example of our research report. So I'm going to leave you with some resources and services and engagement opportunities. We have a MnDOT library, and it is available for you, all of you, on this call. So the libraries, they loan materials. You can use their space. If you have engineers in your office who are studying, young engineers who are studying for the PE, we have materials for that. We have an online Ask a Librarian service. literature searches again that they do. And this, again, these are all available for you. They have access to national databases. So if you're doing your own search and you're running into a wall where you can't access an article, they likely subscribe and can help you out with that. Some of the questions that the libraries get from practitioners include, you can tell that they're trying to bolster what they're doing in their office. What is the pedestrian survivability rate at being hit by a vehicle at different speeds is a question that they got and provided data and facts to a practitioner for that. And then motivators for risk versus safe driving behaviors for young drivers, and that's something that a literature search that they did. Communicating results. Again, we have a great marketing communications team. I'm going to link in the end through the QR code. You can access all of these great ways that they help us get our information out there. And again, just encourage you to stay engaged and informed, particularly in your committees that you're already in. Just encourage you to submit an idea, get together and come up with an idea, maybe every year, every other year, that you would like to become research, or just questions that you have that you want answered. Use that resource; it's there for you. And then also consider joining our technical advisory panels and making sure that your staff do that. We want to make sure that people at all different levels are accessing those opportunities, and we welcome them. And again, a plug to access the MnDOT library. All right. And I'll pass it back to you, Kyle.
Thanks, Jackie. That was great. A great setup for some of the systems in place at MnDOT and how you all in research and innovation are getting those all moving. All right. And now we're going to hear about some of the applications and examples. And I'm going to throw it to Max. Max, take it away.
All right. Thank you, Kyle. Thank you, Jackie. Morning, everyone. Or sorry, afternoon, everyone. Max Moreland, MnDOT Office of Traffic Engineering in our safety section. I'm going to talk about some recent traffic safety evaluations we've done. I'll be just kind of rapid fire going through 5 evaluations, touching on them briefly. These are ones that we did in our office, as well as with a consulting contract we have to do evaluations. So looking at different traffic safety countermeasures that have been put out in the field here in Minnesota and seeing how they have impacted crashes. All right, some of the results I'm going to talk about are in terms of CMF's crash modification factors. So just a quick refresher in case you forgot. CMF, it's a number. If you see a number less than 1, that means that that treatment or that countermeasure is associated with a decrease in crashes. If the number is greater than 1, it's an increase in crashes. It's just a multiplicative, I don't know if I'm saying that word right, a number you can multiply by to see how many crashes you could expect to have if you implement a treatment. So if your CMF is 0.5, you expect your crashes to be cut in half. If it's 2, you can expect your crashes to double. So the first evaluation I'm going to talk about is high tension cable median barrier. Exactly what it sounds like. Cables in the median that provide a barrier. Cables are under high tension. Picture on the left of it there. The purpose of these barriers is to prevent crossover crashes. So if a vehicle on one of these high speed roadways with a wide grassy median leaves the roadway into the median, we don't want them hitting the opposing direction head on. So the barrier, the high tension cable median barrier, is there to grab the vehicles and keep them from interacting with vehicles in the opposing direction. You can see the map here on the right. The black lines show where we have high tension cable median barrier throughout the state, about 800 miles of it throughout the state. So we did a evaluation looking at locations that got cable barrier and looked at the crashes before it was installed, and then looked at the crashes after the cable barrier was installed, and wanted to see how effective it is. And these are the results we saw here. So I've got 2 tables here. The one on the left is for total crashes. So for, again, no presentation is complete without a laser pointer. So for fatal and serious injury crashes, we saw a CMF of 0.682. So again, that number is less than 1, so a decrease in crashes. So about a 32% drop in crashes, fatal and serious injury crashes, when we install that cable median barrier. a drop for fatal and all injury crashes, including minor injuries and possible injuries. And then all crashes actually went up a bit. So there's something that wasn't there before. So now there's something to hit. So we're seeing more crashes total when we put in a cable median barrier, but a decrease in fatal and serious injury crashes, which is kind of our goal with these traffic safety treatments. We want to get rid of those severe crashes, even if it means a trade-off. We're going to have some more nuisance hits, some more property damage only crashes, because again, there's something to hit that wasn't there before. If we focus just on crashes where vehicles are going into the median, fatal and serious injury crashes, very low CMF. So over 60% reduction in fatal and serious injury crashes in the median after we put that barrier in. Again, reduction for fatal and all injury crashes, and then total crashes are going up. So more crashes related to the median than there were before, but much less when it comes to fatal and serious injury crashes. So high tension cable median barriers, they're working. They are reducing fatal and serious injury crashes on our roadways, and they have been shown to be effective, which is why we keep putting them out, have over or around 800 miles on our roadway. So next evaluation, lane constrictors. So lane constrictor is a kind of a lower cost treatment on rural intersections. So these are for 2-lane undivided roadways, higher speed roadways with side street stop. So main line is free flow, side street has a stop. The lane constrictor adds a 4-foot wide painted median. So this is just painting, just striping, with a rumble strip as on mainline as it approaches the intersection. So it kind of constricts the lane for mainline as they come to the intersection. The goal is to hopefully, as that lane tightens up, maybe people will slow up a little bit as they approach the intersection, or at least be more aware of the intersection. They can see more is going on the ground, have more awareness of the intersection, and hopefully reduce crashes or severities of crashes. It also provides some greater separation between the directions of mainline traffic. So we put 66 of these out throughout the state. Again, looked at crashes before and after they were installed. And then we also looked at a control set of intersections that did not get the lane constrictor treatment. Looked at crashes before and after, and this is the result. So this column here, change in the crash rate when we add the lane constrictors, and then the change in the crash rate at those control intersections. So for total crashes, we can see not much difference. They both went up a little bit. No statistically significant difference between total crashes. So the lane constrictor didn't reduce overall crashes when they were installed, is what we're seeing. Fatal and serious injury crashes dropped a little bit at the lane constrictor, but we're talking about small numbers of crashes here. But if we look at fatal and all injury crashes, so severe crashes, minor injury crashes, and possible injury crashes, we did see a statistically significant difference at the lane constrictor locations. PDO crashes, property damage only crashes where nobody gets injured, went up a bit. So we're seeing, again, really no change in the number of crashes that are happening at these sites, but the severities did drop a little bit. So maybe people are slowing up just a little bit, being a little bit more aware of the intersection, giving a little bit more reaction time when they approach the intersection. So not a slam dunk of a treatment, but shows a little bit of promise in some instances. So that's lane constrictors. Right? Again, we're rapid fire onto reflective signal backplates. So these are 3 different signal heads, one with no backplate, one with a black backplate, and one with the retroreflective yellow tape added around it. Purpose of that yellow border is just to make the signals, make them pop, make them more visible, alert drivers, hey, pay attention, there's something here. This is a FHWA proven safety countermeasure that's been tied with a reduction in crashes. So we installed it on a bunch of intersections. We did about 100 MnDOT signals got this treatment. So like the other studies, looked at crashes before and after those were installed, compared them to signals that did not get that treatment. And these are the results that we saw. With the locations with the backplate added against the control intersections, again, not much difference in the total crashes. Fatal and serious injury crashes actually went up a little bit at the backplate locations, but relatively small numbers. Not much difference in the total injury crashes, and a little bit of a difference in the darkness crashes. You can kind of see they do pop in the nighttime, make the signal heads more easy to see. So a little bit of a reduction in darkness crashes at the backplate locations. Slight increase at the control intersections, but not statistically significantly different. So didn't quite see the reductions we were hoping for overall when it came to crash results. This study just looked at MnDOT signals, which already kind of have a lot going for them, kind of the beef supreme, if you will, of traffic signals. They already have lighting. They have 12-inch bulbs. They already had black backplates. They already have a head aligned for each lane of the roadway. So maybe that's why we're seeing limited improvement with the addition of these reflective backplates. So don't want to totally count them out. They might have some impact in darkness crashes. I'd be curious to see how they work on local systems. And we do get a lot of feedback from people that they really like them, which I know isn't how we should determine the direction of our traffic safety funding, but it's a start, I guess. People seem to like them, and more study needed on those backplates. All right, J-turns is the next one I'm going to talk about. Here's a before-after picture of a J-turn intersection. So this is an intersection type on typically rural higher speed expressway intersections where there's a wide median. The conventional intersection, main line's free flow, side street stops. At the J-turn, if you're on the side street and you want to go through or left, you've got to take a right and then take a left. Makes kind of a J-looking hook movement, hence the name J-turn. At these types of conventional expressway intersections, what we were seeing a lot is if a vehicle here wants to go through or left, they would often be getting hit on the far side, right? So if you want to make that movement, you've got to judge two directions of opposing high-speed traffic that are actually pretty far apart. There's a big gap here. So it's hard to judge how much time it's going to take you to get there and how long it's going to take them to get there. And we're seeing some bad results on the far side. Also seeing kind of the mess in the middle at these expressway intersections. People treat them differently. So the J-turn kind of cleans it up. So if you're on a J-turn, you've got to deal with one direction of mainline traffic, make your right turn movement, and then deal with one direction of mainline traffic and make your U-turn movement there. So the purpose of the J-turns is to reduce angle crashes by just focusing on one direction of opposing traffic at a time. So like the other studies, looked at a bunch of J-turn locations before and after the crashes were installed, as well as more conventional expressway intersections. And here's what we found. The locations with the J-turns added 2/3 reduction in fatal and serious injury crash rates, 2/3 reduction in angle crash rates, and nearly a 90% reduction in angle crashes where somebody was killed or seriously injured in those crash rates. So huge reductions. The control intersections either didn't change or even went up a little bit. So the J-turns are doing great out there in terms of what they're supposed to do, reducing those angle crashes, which are tied to those fatal and serious injury crashes. So seeing big reductions in severe outcomes when we put those J-turns in. Total crashes went down a little bit at the J-turns, a little bit more than the control. So it's not eliminating crashes, but it's getting rid of a lot of the severe crashes. So definitely very effective. The J-turns are working really well. We have over 100 of them now on our system, with more planned in the future. And then the last evaluation I'm going to touch on is snow fences. So this study's still in progress, so big asterisk on all the results I share here. It's preliminary. But snow fences, as you can kind of see from this picture, they trap snow by causing it to pile up before it reaches a road, which can increase safety, keeping some of that snow off of the roadway. Snow fences can be structural, as you see here. They can also be living snow fences, trees and shrubs, vegetative. They can also be done with grading, regrade the road to kind of create that area for snow to pile up that's not on the road. There's a lot of smart people at the DOT working with complicated fluid dynamics type stuff and wind blowing and weather patterns to figure out where snow fences would be most appropriate and where to place them when you identify a roadway that could use a snow fence. And we have over 130 miles of long-term snow fence installed, with a bunch of temporary snow fences installed as well. So we did a kind of a before after, looking at snow fence sites, crashes before they were installed compared to after they were installed. And this is what we have found so far. Again, asterisk, asterisk, this is all preliminary data. But looking at the before after results after we install the snow fence, focusing just on crashes from October to April, where winter weather might occur, we did see a reduction in total crashes that was statistically significant at alpha equals 0.1. Saw some reductions in injury and severe crashes as well as winter-related crashes, but kind of the one metric that we were focused on is these wintry surface condition crashes. So crashes where the roadway surface was identified as being covered in ice or snow, seeing a statistically significant reduction in those crash rates, which is the whole purpose of the snow fence. Again, snow fence tries to keep snow off the road. And so if we have less snow on the road, we would hopefully have less crashes related to wintry surfaces. And that does seem to be bearing out. So snow fences do seem to be effective at reducing crashes and achieving their safety goals. All right, I know I went through those quick, so if you have questions, I guess save them for the end, or feel free to reach out to me on that one. No, pass it back to Kyle. Thank you very much.
Good to see those projects in place and how you all are tracking their performance and thinking about them. So I know we got some questions for you, and they'll do that at the end though. All right, we are gonna go to Nicole next. Nicole, do you want to hop on and share your presentation?
All right. Well, thank you for having me. I'm Nicole Morris, and I'm a research associate professor in the Department of Mechanical Engineering and the director of the Human Factors Safety Lab. If you're not familiar with my lab, our basic mission is really structured around reducing the occurrence of roadway and occupational injuries and fatalities. And we do this by taking what we know as human factors psychologists, which is most of our training in the lab, by understanding human behavior and really applying that then to design and our methods to evaluate systems through user-centered design principles. And so we work really a huge variety across the transportation system because human factors is really that intersection between people and systems. And there are a lot of different types of interactions in our transportation systems. So that could be in-vehicle technologies, roadway infrastructure, signage, interactions with larger organizations like police. So we really thankfully have a hand in a lot of different studies or analyses of what's working, what should we try next to try to achieve our goals of zero deaths on our roadways. So I was excited to do this talk because we do work so diversely, and sometimes it feels like my lab is working kind of in all these different directions. But really thinking about this idea about an ecosystem got me pretty excited because it really is an ecosystem of, it seems like every project that we're doing is really maybe more different than the next, but the arc is long and they all tend to kind of arc back to one another in some way. And so I wanted to start by kind of going through 3 or 4 main topics that my lab works on. And this is certainly not all encompassing of all the projects that we have, but I think tell kind of a nice cohesive story of the ecosystem, the collaborations and partnerships that it takes to make these projects successful, and the iteration that we tend to take as we're working bit by bit through these topics. And so the first is really, one of the loves of my life, which is crash reporting. And this is really the lifeblood of transportation safety, because really, as all the great things Max was talking about, we don't know what's working and what's not working without crash data. And we tend to kind of take this kind of narrow aperture as we're looking at crash data, but often forgetting who gives it to us, how and why, and what are the methods that we get crash data. And in Minnesota, it is law enforcement officers that give us this data. And they certainly did not get into the business of being a police officer or a state trooper for the paperwork. So this is a tough job to get them to give us complete, accurate, and timely data. I was really lucky years ago to fall into this collaboration, really jointly collaboration of this funding between MnDOT, Minnesota Department of Public Safety, the Office of Traffic Safety, funding through NHTSA, and then this rich collaboration with law enforcement agencies where we rebuilt the front end of the crash reporting system that's called MnCrash to be really user-friendly and really built hand in hand with police. So you can see some of these things of my early mock-ups of, rather than having them, imagine a 12-point diagram and then pick a location where there may be damage to a vehicle from a single drop-down list. Instead, let's give them the clock diagram and they can just click where that damage is. Or instead of giving them a 64 piece or 64 item list for the collision or the sequence of events, create a nested menu so we can help guide that decision making. And so this system is probably one of the most deployed, most used research product that I'll ever have the opportunity to work on. It's used by all law enforcement in Minnesota, started in 2016, and it gets used about 70,000 times a year because of how many crashes we tend to have. So this has been a really great project and is now really become the national standard. I had a chapter featured in MUC 6th edition that came out last year. And so a lot of states are starting to take our tactics. Some latest findings on this, which is really fun, yet we have such a great system. We still have a lot of work to keep police engaged and writing those property damage only crashes, which is 70 to 80% of our crashes are property damage only. So we really need that data. We can't rely on just the injury crashes. And many police agencies have started to draw back their priorities on crash reporting, saying it takes too long to do the PDOs. And so we've been out doing ride-alongs with law enforcement agencies. We've observed 14 of them in Minnesota, one in Colorado, and more to come there. You can see this is the total time. And so when they say it takes a long time to do a crash report, it's not really true and sort of the way that it gets brought about. But doing crash responding does take a long time. So driving to the scene, clearing the scene, doing the interviews, waiting for an ambulance, waiting for a tow truck, all of that takes time. So we found that in these 14 observations, an entire case, so again, from getting the call from dispatch and clearing all the way to the end, could take as short as 15 minutes in one case, up to an hour and 30 minutes. If they have to collect video data, if it's a hit and run or there's other crimes, it really does take time. But this yellow section on the graph, that shows how much of that time was spent just documenting the crash. And so we find that they can complete MnCrash, and this includes all components of it, anywhere from 5 to 20 minutes. Again, these are all PDO crashes. A more serious crash, like a fatal crash, would take longer. But our PDOs really should be taking, on average, I think we find about 13 minutes for their full completion. And of that average of 13 minutes, we find on average about 4.5 minutes is the narrative and diagram. So just typing up in plain language and then diagramming it. And so to put this in like big pictures, why it matters and why it's really cool to do this work, to really zero in on how long does each component take, that diagram, if that takes about 3 minutes on average, we have 70,000 crashes in the state where they're doing that diagramming tool. You say, okay, it's maybe about $30 an hour with some fringe on there. That adds up to about $150,000 a year that is spent of taxpayer time and paying for the law enforcement officer to do the diagramming tool. So what tools are out there to automate this, to make diagramming faster? Because 3 minutes may not seem like a lot, but times 70,000, that is a lot of time that perhaps we could come up with a really innovative tool to shave off maybe 2.5 minutes. That would be great. So pulling back in, so thinking about how does crash reporting, then the data that we get out of crash reporting, seed some of these other things, our understanding or other research. So thinking about work zone intrusions. So a logical add-on to our data collection with crash reporting is to do work zone intrusion reporting. Again, this is a tough sell. Maintenance workers do not get into the job to do paperwork. And so convincing them to spend time to document intrusions is a difficult task. We worked with the state. MnDOT worked hand in hand with maintenance workers. They gave us a lot of their time and insight and expertise on how do we document an intrusion very quickly in the field, quick on your phone. And so we can increase our knowledge about when and where these intrusions happen. This app went statewide in 2022. And so some of our understanding with that then is still continuing to guide our need to automate this. How do we get this data or information about intrusions without really tasking our workers with this documentation, or how do we help them in real time so we're not documenting after the fact? So some latest research that we're working on, this is in collaboration with MnDOT, LRB, Washington County, St. Louis County, Ramsey County, and again, lots of time and expertise of maintenance workers. Professor Raj Rajamani and my lab have been working on this low-cost sensor. So it's using very low-cost radar a lightweight tool that can be set up at flagging operations that reliably tracks vehicles. And if they're coming in at an unsafe rate, use a car horn that is on the side of that top piece. That kind of looks like ET, I think, but a car horn emits itself to get that driver's attention that they need to slow down. And we find that the workers are really accepting of this. They don't mind the noise. They wouldn't even mind if it goes off more than it maybe should, because they want to be able to focus on their job and make sure that drivers are warned when they're coming up on a flagging operation, which is a really risky environment for our maintenance workers. So again, coming back, another place that we see this crash reporting data really driving innovation and research and focus is in pedestrian and non-motorist safety. So big shout out to some of the folks in the audience that worked on this project with me. This was kind of the big kickoff for our lab to start working in pedestrian safety. And so this was in collaboration with MnDOT, City of St. Paul Public Works, Maintenance, Ramsey County, and Western Michigan University, Ron Van Houten. And so we were looking at the Stop For Me program. Does high visibility enforcement work? How can we use some of these quick build engineering treatments, other non-traditional outreach like our feedback signs? And we found that these combined treatments really were effective at driving up driver yielding at crosswalks. And then it's been really exciting to see how this program has been expanded. It's encouraged other communities in Minnesota to adopt some Stop For Me programs, giving them some guidance about how to use some of this other signage and engineering solutions in concert with that. But we've also seen other cities around the country. Honolulu has reached out that they wanted to implement a similar program. Seattle implemented a similar program following our guidance that they call the report card. So it's been really fun to see this go. What we've been working on more recently, this is with Dr. Curtis Craig, again in collaboration with MnDOT, LRB, St. Paul, and Ramsey County. We had some research that we'd done looking at dedicated versus right through lanes. So for right turning. And so is that dedicated right turn lane safer or riskier for pedestrians? We did a lot of field work at sites with and without dedicated right turn lanes, simulation studies. And now we have this final study that we're working on, just wrapping up our data collection at White Bear and Larpenteur. You can see on the left, prior to that dedicated right turn lane, and then on the right, the dedicated right turn lane. So we're using field data collection and videos to analyze driver movements to see, do we find similar results here at a real site before and after, that we can reduce some of those risky interactions between drivers and pedestrians with a dedicated right turn lane. Similarly, in a collaboration with MnDOT, LRB, Minneapolis, St. Paul, and University of North Carolina at Charlotte, we've been using CCTV, so low-cost cameras at sites where we're doing quick build treatments to look at driver speeds and interactions with pedestrians. This is a site in Minneapolis. You can see some of the quick build treatment that we have here at this site. And so Dr. Ahmed Topki at North Carolina has been working on some AI to analyze just this very short little aperture of the video. They can track these speeds, and you can see before these temporary bollards went in, our mean speeds were 27 miles an hour. And then after we come down to 22 miles an hour. And then the final area I want to highlight is the work that we've been doing in infrastructure and signage. So this was a great study that kicked off kind of a series of research studies looking at our J-turns that we heard from Max are so effective at reducing our fatal crashes, but yet we still get some pushback. Hopefully this will continue to diminish. We're at reaching 100 or more in Minnesota. So more and more Minnesotans will have experienced these, but yet, with each one, you may have new challenges. So using the power of testimonials to encourage people to be accepting of these J-turns as they're going to be coming into their community. But through this work, we did identify a number of navigational errors that novice drivers can make at these intersections. And when you have a bad experience that first time, it does tend to sour people to the J-turn. So we're looking at what kinds of innovative signage or marking might we be able to do, particularly at a compact J-turn where you go straight into the deceleration lane from the stop sign. So I have, this is like cutting edge research or results I just got yesterday, so I'm excited to share. This is plots of participants driving through the intersection. This is a compact J-turn. And on the left, it's a treat. I'm showing the treatment. So that white dashed line is what those participants saw. So this is a pavement marking that is really trying to guide them from the stop sign to go straight into that deceleration lane. So you can see we have more of those blue lines are kind of above that striped line. On the right, it's red, there was no line. So that's just showing the absence of that marking. And the roadway, you can see a lot of those blue lines are below that. And then as you get up to where I have the red box, you can see the tight clustering that we get more drivers early in clustered into that deceleration lane far earlier versus later in the control where there wasn't that marking. And what can happen with those kind of late turns into the deceleration lane is we have increase for side swipe crashes or rear end crashes if drivers are making kind of unpredictable, erratic lane changes, or they change lanes really late into that deceleration lane, or they miss the deceleration lane, they miss the U-turn altogether. So this is really exciting to see this early research that we have, early research finding of the simulation study. We have other components of this study that we're looking at, fishhook signage, but this is really promising what we're seeing here with this pavement marking to guide their movements. So just sort of wrapping up, I wanted to highlight that really the thing I see is, and where I see the patterns of what tends to make a good research study or where do we really learn the most. And so a lot of this is the best studies that we have are from tight collaborations with our community partners, cities, organizations, working with other universities to tap into expertise that we may lack. And we find that, you know, it's really these investment in sound research methods. The study that we're working on may yield results that we're looking for in the moment, but really investing in the development of the methods, then we can carry those forward. And so that leads to good demonstration projects, new research, new innovation, helping our local practitioners implement our research findings. And what's really, of course, Minnesotans love to pat ourselves on the back when people around the country are copying our practices, but we really do see that other states look to Minnesota and are eager to adopt what we have worked on here. So that's all I have. There's my contact info. Please feel free to reach out.
Thank you, Nicole. Great highlighting of those wonderful projects. And these are all fitting together. These conversations are all really fitting together well. So thank you guys for thinking through this so much. And our last presentation before we go to some questions is going to be from Mark. Mark, I'll let you take it away.
All right. Thank you, Kyle. All right. So close out. I'm going to give a pretty brief recap of a lot of the traffic safety evaluations that I've been working on in my office for the past 2 years. These ones were all internal evaluations. And with the help of Jackie and the people over at Research Services, got them all published as well. So they do great work on that end for us when we do these internal ones on top of the research projects that we do for LRRB or with a separate consultant or something like that. So some of this will probably look familiar to some of you, but I'm going to go over a lot of the ped bike evaluations that I've worked on. So this first one I'll talk about was ped and bike safety at rectangular rapid flashing beacons and pedestrian hybrid beacons. So talking about RFBs first, if you go to the FHWA Proven Safety Countermeasures website, they'll let you know that when you install these, yielding rates tend to go up, pedestrian crashes tend to go down. One caveat is that in studies, yielding rates at these treatment sites have ranged from 98% to 19%. My favorite little anecdote is that 19% number comes from the great state of Texas, which I think if you know anything about auto culture in Texas, shouldn't surprise a single soul in this meeting. So just quickly getting to the results. At the time we did this, we had about 300 sites overall in Minnesota, and we picked about 150 for the evaluation with matching control sites. And what we saw was, if we go by percentages, some bigger changes in numbers, but really not much of a huge difference, except when you look at those moderate to mild injury crashes. Those are the ones where we really saw reductions at the RFBs once they were installed. The PDO ones, I don't know how you could have 1,000% increase in property damage to a pedestrian, but I'm guessing some of that could be bikes involved in the crashes as well. Again, it's a small number that we're working with here, so take it with an appropriate grain of salt. Hybrid beacons now. So these are a little more involved. They have more of a positive stop control to them. If anyone's not familiar, there's solid red that transitions to wig-wag red. And then when you see that wig-wag pattern, if the pedestrians aren't crossing in front of you in your lane, you are allowed to proceed. Same benefits here. Ped crashes and total crashes tend to go down at locations where these are involved or installed. And I think that these are particularly effective at crossings like you see on the screen. This is 61 down in Red Wing. It's a multi-lane arterial with a speed limit of 35 or 40 miles per hour. So it's really a good situation for installing something like this. Even smaller numbers that we're working with here. So really not much of a change. We were only looking at 8 sites at the time. So we were going to be dealing with a small number of ped and bike crashes. Really didn't see much of a change here. I think some of the quirkier findings, funny enough, were with the vehicle crashes at these hybrid beacon locations. So at RFBs, our before after showed some reductions for those minor or mild injury crashes. And then we did have a cross-sectional analysis that you can read more about in the report. The only statistically significant findings were when we looked at total crashes. Once we narrowed it down to those non-motorized crashes, the effect disappeared, and mostly I think this just a sample size issue. Same thing for the hybrid beacons. I think one of the funnier findings was that rear end crashes actually decreased in a statistically significant way at those locations. And it's, usually when you install something like a signal, you'll tend to see an increase in rear end crashes. And it was a different finding. I think it might be a case where if we did the evaluation with new data, it might disappear. But who knows? It's funny nonetheless. And then we did see some reduction for bike crashes in the before after scenario. So once we broke out those ped bike crashes, we did actually find a statistically significant reduction in bike crashes. I think now we're going to talk about ped bike safety at roundabouts. So this is one that I finished in 2023. I had about 95 roundabouts and 93 control sites. Using some of the criteria on the screen, these were mostly meant to focus on those ones in urbanized areas. 3 types of analysis. So we did a before after for ped bike crashes. We compared with some traffic signal locations and also some urban stop controlled sites, both side street stop and always stop as well. Just real quick run through the results here. Generally very good findings with the total vehicle crashes. Fatal and injury went down across the board. PDOs went up. That's a pretty standard story for roundabouts. Once we narrowed it down to ped bike crashes, we see bigger percentage swings, but still I think a pretty good story that we're telling here. We saw fewer K&A crashes, fewer injury crashes overall, and those PDOs did go up a little bit. Compared to traffic signals, roundabouts look very good. The crash density was lower across the board at roundabouts compared to signals. Again, take it with a grain of salt. We're dealing with small numbers here, but I think especially when you look at those A crashes and B crashes, those are some very, very good numbers to see that the roundabouts have lower crash numbers across a 5-year span. And then with the stop controlled intersections, it's kind of a mixed bag. Roundabouts didn't really win any of the comparisons. One of the bigger and more interesting things out of this was that all-way stops are kind of a safety rock star that nobody pays attention to, because people aren't huge fans of them operationally, but from all the trunk highway all-way stop intersections that we had in this evaluation, there were no K or A ped bike crashes. So they're a treatment that I don't think gets enough credit either for the safety benefits that they have, for the costs that they have as well. So in general, what this evaluation told us was that when you install a roundabout, it's probably going to be safer for peds and bikes, and those K&A crashes, especially for vehicles, are going to decrease. One more thing we did with this. So a few years ago, I think Michael Pettish, when he was with our Office of Transit and Active Transportation, worked on a research project with a few people at the U of M to come up with a AADT for non-motorized users. And it was Metro only at the time we looked at this data. But we had kind of a rough estimate of roundabout and traffic signal entering volumes for bikes and peds. So these numbers are purely guesswork. The crash numbers are not, but the rates and the volumes are, a very rough estimate, but it's still a useful comparison, I think, to look at it and see fewer overall crashes for roundabouts, but again, on a lower volume. So the rates are pretty similar when you look at the two in the metro. With more data and some more refined volumes, we might be able to tease out more effects here. But for now, when you look at just metro and just estimates of ped bike volume, we're not seeing the same difference, I guess, that the earlier comparisons did. The last thing I'll talk about is an evaluation that I'm working on right now. So this is ped bike safety at transit stations. So we compiled from about 12 different providers. The big ones are on the screen there: Metro Transit, MBTA, St. Cloud, Duluth. I think Moorhead is in there. So there's some pretty big systems. And we basically took those locations and overlaid them with some other associated characteristics. The big ones were near signalized intersections on divided roadways. We wanted to really look at high frequency routes. And then also the space score. We've seen some association with our space score at MnDOT and ped bike fatal and serious injury crashes. And we wanted to see if that effect still holds up when we look just at transit stations too. Preliminary findings. So there were a few areas where we saw an overrepresentation of those fatal and serious injury crashes. If basically you're on a divided road with a signal, and this is for the transit station itself. If it's on a high frequency route, if it's in one of the statewide core cities, so Minneapolis, St. Paul, Rochester, Duluth, St. Cloud. If the space score, it varies, but depending on where you are in the metro area or in the core city, the space score does indicate risk for those K&A crashes, and then population density as well. These are obviously preliminary, and I don't think they're going to surprise anybody that where you have more people, you're probably going to have more K&A crashes at or near transit stations. But again, I think it's useful to look at it again. And this is consistent with what the Met Council found too. So it's, if anything, reinforcing the facts that we have out there already that, transit stations are just by their nature almost a riskier area than a regular signalized intersection. So that's what I've got. My contact information is on the screen. And I will hand it off now to Kyle to wrap up.
Awesome. Thank you, Mark, and thank you all. If the presenters want to come back on camera, I have a couple questions for folks to get us started, and I saw that some were answered while we were going, so thank you, Max and others and Jackie who answered some questions. But please, again, attendees, feel free to drop other questions that have come up into the Q&A, and I'll bounce back and forth between those and my own, and it would be best if you put them in the Q&A right now because I can only look at my own notes in the Q&A and not the chat in all three. So otherwise I'll just do all my questions. One thing that I was struck by y'all is kind of the through line around the challenges of doing the work and then talking to various stakeholders about it, whether it's, individual users, all of us on the streets and whatever mode we're moving, other academic partners, Nicole, other practitioners, y'all, MnDOT, everybody. Can you all just talk a little bit more about like what are the steps or what are the lessons you have learned around when you have this research or when you have a project that you're doing, how to best amplify the conclusions beyond just like the core group that you're working with or within your own offices?
Sorry, that question was for me.
So tell everybody, but
Okay.
well,
All right. Well, I'll start because I've unmuted. Yeah, I mean, I think so I try to go kind of like as many avenues as I can to try to share the message. And so this is, speaking at national conferences, trying to publish peer-reviewed journal articles to get it sort of out to a wide audience. But the other thing is I really just don't tell anyone no who ever asks me to come speak. So if it's somebody's American Legion group, they want to hear me come talk about research, or a local community, a district council. And so kind of everywhere in between, I think it is really my responsibility as a good steward of all of these taxpayer dollars that have been used to do the research to share the message with every single audience that I can. And it is tough, and it takes time, and it takes time away from other, research projects. But I think that's really critical, is to find audiences early and often at every level to try to share what we have learned. And so that's really the approach that I have taken.
I can continue that thought too. My thoughts with that, I had mentioned some of the tools that we use to communicate with people, the research outcomes. And I feel like our office has really adapted how we disseminate information from the traditional research report to some guidelines, some tools, Excel tools, different things that, depending on the audience, what's going to be most useful to them. And then I think one thing that we are also finding through, we have a value of research pilot that we're doing. We're finding that technical liaisons are just, they're the chairs of the technical advisory panel. They're the practitioners, and they're really the best champions for next steps as well. And whether or not this information is useful and gets implemented. Those are my two learnings, I think, and takeaways.
Thanks, Jackie. Mark or Max, I'm curious from your perspective, when you've done the really detailed studies on the particular projects, how do you see things moving forward from there? How do you communicate those with colleagues and others?
I can echo a lot of what Nicole said, is just getting out to different groups. I apologize. There's probably people on this call who have heard me say these same things before, so apologize for the repeats. But yeah, kind of getting out and doing the old dog and pony show, as Mark and I say, sometimes going around and talking about the results that we've shared. And often it's just the people who are interested in these types of things who come to these things, but sometimes we'll get in front of a group of folks that may not have opted into that type of a message before.
And I think one more thing that these evaluations we work on help with is counteracting, maybe that's too aggressive a word, but kind of like going against the public narratives that can be out there sometimes as well. So like I worked on a trucks at roundabouts evaluation because a lot of our districts had been hearing from people that roundabouts are less safe for semis because of the rollover risk. And after that evaluation, the findings were, yeah, some of our older roundabouts and their design details and the way their curbs were built did increase rollover risk, but our geometric standards unit has made some changes that really helped that. And overall, your K&A crashes or your injury crashes to truckers are lower at roundabouts, even with that rollover risk. So we do end up helping our districts around the state a lot with public engagement with the results of these evaluations as well.
Yeah, thanks, y'all. Great answers. I have a couple more, but I'll jump to some of the questions that we're seeing here too. And I think a good one from Howard is focusing on, you all shared a lot of examples and great projects and research and implementation that have really shown some really positive results in reducing some of the really severe crashes. Do you all have thoughts on obviously the crashes are increasing, and the question is sort of like as we're implementing these individual positive strategies and tools, we're obviously still seeing a growth in some of those crashes and deaths and other serious injuries. Do you have broader thoughts on where those two things intersect? How do we start to scale up these pieces and think about that broader challenge we're facing?
I think it's kind of forever going to be an issue as population grows. There's going to be more traffic on the roads, and so we're going to kind of have more potential crashes to deal with. But fortunately, I would say if we compare where we're at now to decades past, we have been seeing decreases in some of the rates, in fatality rates. But if we look more at recent events, we've been seeing an increase in fatal and serious injury crashes. And the tough thing is we have a huge network of roadways. We have 100 J-turns, but we have 200,000 intersections throughout the state. So it's kind of trying to identify where can we get the best bang for our buck on our network and hitting those spots. And there's a long road ahead of us, I guess, in terms of identifying problems on our roadways, but just job security, I guess.
And I'll add to that it's always a challenge as we're trying to weigh out, are crashes overall going up, or is it the serious injuries, or are crashes more serious but not really changing? And again, a lot of this comes back to how many property damage only crashes are our law enforcement partners writing. And so if you look at communities like Duluth or St. Cloud, who have all but abandoned their efforts in documenting property damage only crashes, that will make it appear spuriously that we have an increase in serious crashes relative to total crashes, but that may not be the case. It's just the data that we have. And so it's really important that we continue the education of the importance of property damage crashes and this false conclusions that we can sometimes draw to whether or not things are becoming more serious when people are crashing. It may be true, it may not be true, but we really need those base rates of property damage crashes to know what's really happening.
Yeah, thanks, Nicole. I was also struck to the question and to your all's presentations as well. We know that obviously in all these circumstances, speed is a huge factor. And Nicole, I was particularly struck by the example you gave with the pop-up intersection or the pop-up interventions and really being able to show that description of how the speeds changed at every percentile in the overall. And so I think that's obviously a contributing factor to some of the crashes and fatalities we're seeing in the last 5 years as well, because we know that some of the aggressive speeding that is happening, not just in Minnesota roads, but nationally, is contributing
Absolutely.
seriously to that too. So it's good to see that there are also some of these implementations that can really drastically impact that on local roads and big roads. I had another question as we're still giving folks another opportunity here to add in the last few minutes here. I'm curious, these are all kind of discrete projects where you're looking at evaluation of a particular intersection or particular topic, Jackie, on some of the broader R&I pieces. From your all's perspective, this is a little bit of a communications question, but I also think it's it's more of a cumulative research question. How do you all think about like the building blocks of these projects? One of the other through lines for this, all four of your presentations, was just the process we go through, right? Starting with R&I, starting with the offices, thinking about what the challenges are, where we want to address the challenges, and how. I'm really also interested in when you all think about these individual pieces you've worked on, these projects you've worked on, how do you think about like the next steps, right? So you can show a conclusion and this is a better outcome. How do we try to move those into projects, or how do you try to promote those across the departments and see them being built with the evidence you're accruing?
Yeah, I can kind of think of an example in the reverse, as we did an evaluation of rural and intersection conflict warning systems, the RICWIS system, and found that they weren't as effective as we wanted them to be. So kind of started phasing those out, not putting our safety money towards those systems. But now that we've seen evaluations for certain roundabout features or J-turns that are effective, those kind of, they're less alternative intersections now. They're at the forefront. This is an option right away to be considering. So it's kind of a mindset shift when we think about things that we can be doing on our roads. It's not a strange experimental thing anymore. It's quote proven in Minnesota to be working.
Thanks, Max. And do those get incorporated like into the state highway safety plan? Do those get incorporated, just kind of that nitty gritty, there's a lot of process to understand how those things move. So does that just get formalized in the documents that you guys
Yeah,
create?
yeah, and yeah. When we start planning ahead, they can be included in those types of plans. We can start using HSIP money or highway safety money for those types of things. Yeah, different metrics can be moved. Yeah.
Yeah. Mark, you got into that?
Yeah, I wanted to add one thing. So J-turns are a good example of, the research. Max has done a couple of reports on the safety of J-turns. And once we had that foundation of safety data for them, that led to the J-turn tech memo that our benevolent superior Derek Lohr has been working on for the past couple of years, to really enshrine those in policy more, because we know how effective they are at reducing fatal and serious injury crashes out on those divided expressways. And it's leading to the point where we really encourage, when a district's building a roadway like that, to limit the number of full open accesses that they have, and instead ask people to go down to make that U-turn a few hundred feet or 1,000 feet, instead of trying to make that left out. So that's another way where, not just into like the SHSP or HSIP program, these evaluations can lead into policy changes as well.
Yeah, nice. Thanks for highlighting that. I think it's good to see those pathways. And I think particularly on the research community side, it's as Nicole, you were mentioning the audiences you're sharing it with, it's not always direct. You don't always see the direct implementation, right? Usually, right, not after the research report. It might take a couple of years. It might take a couple different paths to find its way, but it's nice to hear about that process where it can really get built into the practice and start to be a part of how you all communicate about it. Well, we are right at 2:15. I think there are a couple specific questions that folks had, and I would encourage you to follow up with those presenters that highlighted those to dig into those details. I think those are some great examples if you want to learn a little bit more about some of the conclusions from the studies and pieces that folks highlighted. Just shoot those folks a note. We'll make these slides available. And I think, Jackson, you're going to pull up the QR for the survey here. Thanks. If you want to evaluate the event today, the webinar today, there's a Qualtrics link in the chat, and you can also use this QR code. Leave that up for a second. And then lastly, I just want to thank everyone for joining us today. And you can share more thoughts or reflections about the program. And if you want to follow Minnesota Towards Zero Death on any social media platforms, here are those websites and the general website for the TZD program. We would welcome you to become a regular follower of the work that's happening here for future webinars and learning more about all this great work that folks are doing across the state and our communities to help keep us safe and moving along. So appreciate the panelists. Thanks everybody for sharing that work, and really appreciate you taking the time and sharing your expertise. And for all of you who took some time out of your day today to join us and learn and share some questions, appreciate you doing that as well. I hope everybody has a good rest of their week and stays relatively dry with the moving rainstorms here. Take care, everybody.